Good morning. Today we are going to talk about the third problem, which is autocorrelation. What's autocorrelation? In the model y equal beta 1 plus beta 2x2 plus u, it's assumed that the correlation between errors in two different time periods is zero. So we can write it as if you are going to find the error term over number of observations, the error term this year and the error term in the previous year, the relationship or the correlation between them is zero. So this is the main assumption. But in some cases, this assumption is violated. If this assumption is violated, this means that there is a linear function or linear correlation between successive error terms. And this is the problem of multicollinearity. It's commonly found in time series data. So the problem of autocorrelation is highly correlated to time series data. But why this problem arises? What are the main causes of this problem? There are five main causes or sources of autocorrelation. Number one, nature of economic and business variables. Most economic and business variables tend to move together over time. Say, for example, consumption expenditure is going to increase during expansion and decrease during recession. Also, GDP is going to increase during expansion and decrease during recession. So they are going to move together in the same direction over time. This may cause an autocorrelation between error terms. So this means that observations of an economic variable are expected to be interdependent over time. Number 2, variable transformation. In some econometric model, variables must be may be measured by their change instead of their actual values. So say, for example, this is the actual values for the consumption function. But instead of using this form, you are going to use the change form. So this is the change or the first difference form. So if model number 2 is used, there will be a strong possibility that there is a problem of autocorrelation. Number 3, model misspecification. If the model doesn't follow a well-known theory, autocorrelation will occur. For example, in economic theory, total cost function is a nonlinear function. If by mistake total cost function is specified as a linear function, just like this. So if you are going to use this form by mistake, so this may cause a problem of autocorrelation. Number 4, autoregression or lags. In some econometric theories and models, the dependent variable in the current year depends on its own value in the last period. Say, for example, your consumption today is going to be affected by your consumption last week or last year. And this is known as random walk hypothesis. So lags mean dependent variable in the current year or the current period depends on its own value in the last period. Random walk hypothesis. So we can write it as, say, consumption at time t equals the intercept plus C1y plus C2 C t minus 1 plus ut. So this is the autoregression or the lagged value. Using lagged dependent or lagged independent variables may cause the error term to be autocorrelated. Number 5, non-stationary variables. What's meant by a stationary variable? A stationary means its variance and mean doesn't change over time. So using the time series data requires that the variable should be stationary in order to avoid the problem of autocorrelation and non-stationarity as well. So if the variable is non-stationary and you are going to run regression using non-stationary variables, this may cause a problem of autocorrelation. So these are the 5 main causes or reasons of the problem of autocorrelation. How can we detect the problem of autocorrelation? Mainly, we are going to talk about only one measurement or a method of detection, which is Durbin-Watson test. The most common test used in order to detect autocorrelation is Durbin-Watson test. Or known as D test or D statistic. Durbin-Watson is calculated as summation error at time t minus error at time t minus 1 all squared divided by summation e at time t squared. Or we can write it as sum of squared differences of residuals divided by RSS sum squared residuals. If the residuals are autocorrelated, they will be following an autoregressive scheme. They are following the Durbin-Watson test can be only performed if the error term is following the first order autoregressive scheme. So we can write it as follows. U at time t equals rho u t minus 1 plus epsilon t. This equation is known as first order autoregressive scheme. What's meant by first order autoregressive scheme? Or what's meant by autoregressive scheme in general? And then we are going to talk about the first difference. Autoregressive scheme is an effect when a variable is regressed on its lagged value. Or in other words, if the variable is regressed on its lagged one period variable, this is known as first order. So if you are going to regress y at time t, y t minus 1, this is first order autoregressive scheme. Regress the variable on itself lag one period variable. So the length of the lag will decide the order of the autoregression. So if you are going to lag to regress the variable on its second order lag, so yt minus 2, so this will be second order scheme. This is first order and so on. If it's at t minus 3, it will be third order scheme and so on. We can write, instead of first order scheme, AR 1. This means first order scheme. AR to second order scheme and so on. So in case of our equation of ut equals rho ut minus 1 plus error term, this is a first order scheme. The variable is regressed on its first order or first lag or difference. So this is a first order scheme, AR1 model. Rho is the first order coefficient of correlation. Or the coefficient of autocorrelation of lag 1. What are the main properties of AR1? The error term in year t is correlated with not only its value in the past year, but also is correlated with its values in several years in the past year. So this means ut is not only correlated with ut minus 1, but ut minus 1, ut minus 2, ut minus 3, and so on. So it's correlated with its value in several years. Number 2. The value of rho is constrained between 1 and negative 1. This means that rho can be positive or negative. Number 3. The first order scheme has proved to be more powerful in empirical words than higher order autoregressive scheme. At the same time, it's simpler and more operational. Next time, you are going to talk about the decision regarding Turpin-Watson, and when, based on the value of Turpin-Watson, we can determine that we have a problem of autocorrelation or not. and what are the possible solutions for this problem. Thank you and see you next week.